my question to you is, are there any problems? I asked you to work on problems, even problems up to number 30 in the chapter 5 homework. Are there any problems that you'd like to see me do? Any of the even problems? Okay, so this is the same reaction I got in the first section, which means I don't think people really worked on problems. So I'm going to do some more in 5.2, and then what we're going to do is we're going to break into small groups, and you're going to go and you're going to start doing this homework together so that you can call me over for assistance or call me over to make sure that you've done the problem properly. Does everybody understand that? So I'm going to do some more problems in this chapter, but then I'm going to make you start doing the dang homework, because look, I think we set aside a bunch of weeks for this because it takes practice. And this is what I'm going to tell you. You can watch me do the problems and it will make sense to you all day long. But that doesn't mean that you have any clue how to do it on your own. Okay? All right, so I had done up to, I think, problem 31. So let me continue by doing some odd problems. Let me do problem 33. Okay. We have to prove, this is 33, we have to prove P or not X and Q, okay? We have P and X, and we have Q. Okay, so remember, I'm going to explain how I think about this, and I'm going to do it according to an algorithm, which, I mean, I can look at it and know immediately what to do, but I'm trying to give you a way to think about the problem that will help you always figure out what to do. It's not necessarily always efficient. So the first thing I would do is I would look for this whole mess in the premises. I don't see that. I would look for the opposite of this whole thing in the antecedent of a conditional so that I might get what I need by modus tollens. I don't see that either. So when I've exhausted those two straightforward possibilities, I really need to look at what I'm trying to prove and look at the main operator, because that's going to give me some clues about different ways to go about it. This is an and. So what that tells me is this. I can go get this piece by itself, and I can go get that piece by itself, and then I can put them together by conjunction. Everybody understand that? So I'm going to separate the problem into two different problems, okay? So I'm going to look for P or not X. I don't see that. I don't see its opposite in the antecedent of a conditional. So now I'm thinking about its logical operator, and it's an OR, and this gives me a big clue. Because if I can get a P, I can add on or not X by the rule addition, okay? So all I need to get this thing is to find a P. There is a P, and it is in a conjunction. So this is like saying I have burger and fries, from which I can say I have a burger, okay? So I know that's going to be my first step. P from 1, and that's simplification, okay? To be clear, you may only simplify conjunctions, okay? Don't simplify ors, don't simplify if-thens, or if and only ifs, only ands, okay? And you can only simplify to the first conjunct, okay? So now I got P. Why was that important? Because I said I could add on the or not X. So let's do that. P or not X from 3 by addition, okay? So I've got half of my problem done. The other thing I need is Q. Well, that's right there, okay? So all I need to do is put 2 and 4 together. So P or not X and Q, 2, 5, and when I'm putting them together, it's conjunction. Okay? And I'm done. Okay? So let me do another. 35. Okay. We have to prove not F if only if G and H. Okay? One is F if and only if G then Q. 2 is not Q then H, and 3 is not Q. Okay. So I've got to prove this thing up here. So the first thing I'm going to do is look for what I need in the premises. I don't see it. I'm going to look for its opposite in the antecedent of a conditional. I don't see that either. So now I'm going to look at what I'm trying to prove. I'm going to find the main logical operator, which is right here, and that's going to give me some ideas about what I can do. It's an and. So what that tells me is I can go get this part, and I can go get that part separately, and then put them together by conjunction. So the problem has now divided in half. So let's focus on this half. Not F if and only if G. I go look for it in the premises. I don't see it. So the next thing I do is I look for its opposite in the antecedent of a conditional. And there it is. Okay? This is the opposite of that, and it's in the antecedent of a conditional. Why is this important? Well, if I can find the opposite of the consequent, I can do modus tollens and get not F if and only if G. So let me see, do I have the opposite of the Q? Yeah, right here. Okay, so that's going to be my first step. 1 and 3 are going to get me not F if and only if G. 1, 3, modus tollens. Right, half the problem done. Now I need my H. Look through my premises, looking for an H. There's an H. It is in a conditional. It says if not Q, then H. I need to be able to say H, so that means I need to find a not Q. Holy smokes, there it is, right? So 2 and 3, not Q then H, not Q, therefore H. 2, 3, and that's modus ponens. Okay. Now I have the two pieces I need on 4 and 5, so I can say not F if and only if G and H 4, 5, and when I'm putting them together like this, it's called conjunction. Lots of people want to say addition right there, but addition is when you're saying or blah. Okay, this is we are conjoining them, and we're done. Okay. That's 35. So let me go to 37. 37. We have to prove G. I think I need to choose a better marker. Not L or M, or A then G. 2 is A, and 3 is L. I am in 5.2, right? This doesn't look familiar. In the right place. Okay. G. All right. So I'm going to look at my premises for a G, and I see a G. It's not by itself, but there is a G in here, okay? So let's forget about the other part for a moment and just look at that. A, then G. I could get the G if I could find an A. Does everybody understand that? But first, I need to get this part, okay? So how would I get this part? This is an OR, okay? And so suppose we have box or circle, and we want the circle, we need to go find a not box, and we can do disjunctive syllogism, okay? So I need to find the opposite of not L or M. I need to find L or M, okay? I don't have L or M, but I have L, and that's gonna be enough, because I can say L or M from 3 by addition. Remember, we can say or anything we want, so I pick M. Okay? All right, now that I have this, look at 1 and 3. I've got this arrangement now, disjunctive syllogism, blah or this. I have the opposite of this, so I get that. So I get A, then G from 1 and 4, and this is disjunctive syllogism. Okay. Remember, we are after the G. Now, this says if you have an A, then you get a G. There's an A. So I can say G from 2 and 5, modus ponens, and we're done. Okay, so I hope that you're noticing that I'm kind of thinking about the problems in this methodical, does anyone do programming in here? A recursive procedure? It's like, I'm following this procedure and I do a step and then I start the procedure over again. I keep, right? So we can write a recursive program to solve these things if we can come up with the proper algorithm. 39. Prove K. Change this out. Prove K. What do we have to work with? We have Q or R. We have not, and some big monstrous thing, L and not M or O or